and welcome again to the Rotary Club of Livermore. We are just going to get rolling here right at 12:30. All right. To start us off today, let me see. Trudy, are you doing anything right this very minute? Would you lead us in the Pledge of Allegiance? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you. That was magnificent. Wow. Alrighty, up next, we've got our songsters with Michael and Stu and Tim, Dave, and we've got a variety of folks up here. Oh, and True. Gosh, you were just, you don't have
Right here. Right here. I need to be right here.
Yeah. I'm so
One of
glad
my
you
right
got
eye,
those.
my right eye. Why are we doing this song?
Oh, yeah.
Tell them why.
Yeah. Hi, folks. We have a song for you today. We would like you to sing along with us. Our guest speaker is going to talk about soils and soils. Plants need soils and they need sunshine. So we're going to sing Good Day Sunshine. 1, 2, 3. Good day sunshine. Good day sunshine. Good day sunshine. I need to laugh. And when the sun's out, I got something I can laugh about. I feel good in a better way. I'm in love and it's a sunny day. Good day sunshine. Good day sunshine. Good day sunshine. We take a walk. Sunshine down. Burns my fingers, they touch the ground. Good day sunshine. Good day sunshine. Good day sunshine. And then we lie beneath the shade tree. I love her and she loves me. She is good. She is fine. I'm so proud to know that she is mine. Good day sunshine. Good day sunshine. Good day sunshine. Good day sunshine.
Thank you very much. Okay.
That'll grow on you.
That was us that was going to grow on. So our guests are going, I didn't know there was a song involved. Well, a lot of the board meetings that you see might go better if there was a song at the beginning of the major issues there. All right. And Sheila, who is scheduled to do our thought for the day, is out sick today. Luckily, hopefully just with a minor illness and not a major medical issue. But Gordon, would you throw up your hand and come on up here? You told me that you have a thought that we should ponder today.
I think it kind of relevant today. Expression from Sir Winston Churchill. Democracy is a terrible form of government. However, the world is yet to come up with a better solution.
Have you ever noticed how much Gordon and Sheila look alike? If Gordon just had longer hair, maybe not, maybe not. All right. We don't do this with one or two people. Here we have a whole community that helps us out. We've got Joe. Oh, that's a nice picture, Joe. And Kathy is our publisher, and Irv is photographing us today. Photographing. Okay. And Dennis is working on our audio visual. Were you greeted by Gowd when you came in? Yes, he did a good job. All right, nicely done. Trex and Bob is here. Hey, So a question for all of you, if you have not bought your raffle tickets today, we are getting down to it. There are exactly 4 marbles. Now, the proper color marble will get you take over $400 for your share of the pot. Another marble will get you essentially a bottle of wine. Is that correct? And the other 2 would basically be a nice donation from you. All right. So you have got 50-50 shot at doing quite well. All right. So if you want to wander back, Bob's there. If you want to throw up your hand at some time in the meeting, catch his hand, he will come. He's taking cash, which is his very favorite. But there are other ways to work this out if you do not have cash on you. So speak to the man in the back. All right. Web misbehaving. I get it. It's like a threefer on that one. Think deeply about that and you'll get it. It's Kathy Coyle, Public Outreach is Kelly Bowers, and videographer, who will be starting to video more consistently is Niall. All right. Introduction of visiting Rotarians and guests. We're going to start with guests excluding our speaker. Okay. So we're going to introduce our speaker in a little while. But if you're not a Rotarian and you're a guest, if you would stand up at this particular time, and in theory, you have a Rotarian nearby you who's going to take on the obligation and the joyful duty of introducing you. So there we go. We have a microphone in the back.
Mr. President, I'd like to introduce my wife, Mary, and maybe a potential member.
Woo! Welcome. Okay, up here at the front table, or are you going to do, Michelle, you're going to do it again back there? All right, we'll do that, and then we'll come to the front table up here.
Thank you, President Mark, fellow Rotarians. It's my privilege to introduce Denise Watkin. She's on the Board of Trustees for UC Merced, as well as Ed Klotzfair, who is the president of the foundation for UC Merced.
Yay, welcome. Thank you for coming out. We know you came just to see us. Well, partly, yes. All right. And Lynn, are you going to introduce, boy, you've got a table there.
Welcome again. We brought a huge contingent of people from UC Merced, so I'm going to pass the baton.
Hi, Lisa Puller-Carlson, Associate Vice Chancellor with UC Merced. It's great to be here today.
Hi, Brooke Gadasi from UC Merced, Director of Development.
Hello, Monica Sozino, Director of Corporate Relations.
And Lynn, you've got
And
one more
one-
introduction here. Don't forget
Who
that
could
one.
that be? Oh, yeah. Last
Yes.
but not least, my wife, Joan, of 44 years.
Yeah. Well, welcome everybody, and especially those from UC Merced who came out to join us today. We're very excited to have you. All right, visiting Rotarians. We know we've got at least one in the room. Where are we? There we go. Stand up. You know the drill. Okay, and President-elect Pat.
Yes, President-elect Mark and fellow Rotarians and guests, it's my to introduce Sarah Palmer from the Morning Club. And Sarah is president-elect of the Morning Club. And she's been visiting a number of clubs within the immediate area. And I'm thinking about following in her footsteps. That sounds great, Sarah. Thank you.
All right, you guys know the drill. Hello, Sarah, and welcome. Thank you. Are there any other visiting Rotarians? All right, thank you all. Up next. Announcements. We should have one. What do we got next? Birthdays and anniversaries. Dave and Trudy, you're up.
Okay. Okay.
Good afternoon. I am going to announce birthdays and anniversaries. We'll start with birthdays. My husband has a cookie for each of the birthday boys and girls. The first one is Kim Wait, I saw her back there. Her birthday was November 2nd. It's hard to weave back there. Okay, the next person is Pat Coyle. Pat here? Okay. Extra cookie for, oh, okay, Kelly Bowers, not here? Oh. Brian Mile? Yay! November 14th. And Michael Ferrucci, also November 14th. John Lynn, November 17th. Nope. Roland Ellingson. Okay. Tori Gibson. Okay, good. We're getting cookies extra. Kathy Streeter. Nope. And Bill Nebo. Wow. Okay. Lots of extra cookies. Okay. Happy birthday to you. Happy birthday to you. Happy birthday, dear Rotarian. Happy birthday to you. Okay. All right, anniversaries. Barbara Limberis is not here, you told me, Jill, right? Okay. I don't know, she was married on November 9th. I don't know how many years. Okay, Christian and Catherine Chukwuma are celebrating 22 years. Nope. All right. Barbara and David Rounds celebrating 44 years. And Lynn and Joan celebrating 44 years on November 29th. And Jack and Joyce Mills celebrating 65 years on November 19th. Okay. I don't know this song.
Yeah, you do.
Okay.
Okay. So every time we do this, we have to come up with the song. So I figured I'd spring another song on these guys. So we have not rehearsed this. I know you're the first to actually hear it live and in person. Okay. You want me to start it? Okay, ready to go? Let's see. Well, how can you say you will when you won't? When you don't, how you feel. Tell the truth now, is love real? Well, honey, don't. Honey, don't. Honey, don't. Honey, don't. You say you will when you won't, but honey, don't. Okay, where are you? Baby, well, you ought to know, like the way that you wear your clothes. Everything about you is so doggone sweet. You got that sand all over your feet, but honey, don't. Oh no, honey, don't. Oh, we can do it. Honey, don't. Honey, don't. Say you will when you won't, but honey, don't.
Yep, all I can say to that is wow. All righty, next week, we're trying something new. So we're gonna have a potluck. You have collectively signed up for something. So Joel, are you gonna remind us how you're gonna remind us what we're supposed to do?
Let me remind you of my reminders to remind you. Yeah, we have a pretty good sign up list. I'm going to be bringing in an extra table and maybe a couple of extra trash cans. Remember, we do need to clean up after ourselves with this. We have lots of food. Our typical meeting, if you add 2 standard deviations to the average attendance, is about 58 people, and we have enough for 72. So there'll probably be seconds. It should be good. See you then.
So the key to this is that you remember what you signed up for. So Joel, are you going to remind people maybe the night before to kind of go, oh, shoot, yes, or the day before?
I certainly will. And even though I didn't include it on the sign up list, if you're okay with just having ice water, that's what you're going to have. But some people are thinking they could also bring something to drink. Mary Dyer, one of our friends at Rotary, has signed up for drinks. And if you'd like to bring something, that should work too. Is wine okay? Sure. And wine is okay.
Yeah, there was unnatural clapping in some areas of the room there. Yes. All right. Up next. Also on Wednesday, November 13th, that's next Wednesday, we've got Wine Wednesday Social at JMC Cellars. It is at 5 p.m. we start those? Yes, it is at 5 p.m. That's 5 o'clock in the afternoon. So we're going to be at JMC Cellars at 6800 Greenville Road. That's the darn near southern end of Greenville Road. If you turn south and you run out of road, you're pretty close. Wander around a little bit, you'll get there. All right, 5 o'clock, bring a friend, bring a potential member, bring both if you can, in the same person or different people. All right, and we are making progress. So you'll remember last week that we had the owner of the ale house here, one of them, who was promoting their nonprofit, which is essentially to make over rooms for children who are facing critical diseases. So there's a lot of things they can't control when they are going through those sort of events. And one of the things is because they're isolated from their friends, a lot of times from school, and they spend a lot of time by themselves. This makeover involves both for them and for the rest of the family members, something that sort of gives them something to look forward to. So at the club, we committed to $5,000 and we divided up the tasks, okay? The task of growing the beard fell to me. So you'll see that for the first time ever, I sort of have now 4 days worth of beard growth. It is the 6th. I had to show a photograph on the 2nd of me being clean shaven. So I did that. So I've checked the box there and we're 4 days in. So we have, and from now until December, I'll remind you of the date, but it's the first part of December there when we have to be done. We get one meeting in December to sort of wrap things up. Our goal is $5,000 and we're just under $900 raised right now. When you go into the app, it can be slightly glitchy because we're using it in a way that it's not designed to do, which the main thing to do is go in, click the box and simply scroll down and enter your own information in there. The information entered in there could be mine. It could be the person who gave immediately before you as to their name and email address. All you're getting is their name, so it's not very fun. Not like their secret information like their credit card. But go fill your name and your email address in because that way you get a response back and a receipt. Either way, the money goes through, so you don't really have to do that, but it's easier if you sort of put your own name in there. That way the receipt comes back to you for that. And we do have, you got sent an email from Joel. Every week we'll sort of resend something out so you don't have to dig too far through there, but we're making good progress. But if you want to keep seeing me grow my beard, we sort of need to continue to make progress on that. So we're excited about that. All righty, up next. Next week, we've got Dennis and a panel of Las Positas College veteran students celebrating Veterans Day. So we are very excited about that. We have an amazing program out there at Las Positas College, actually one of the very best in the state. And so we'll hear probably a little bit about that and a little bit about our veterans. So looking forward to this. Is it going to be a good program, Dennis? Fantastic, he said. Yes, so that's why you don't ask a question you don't know the answer to when you're at the microphone, you see, because people like that don't support you. All right, this week, however, we have essentially Dr. Emerson Byrne, UC Merced, how the soil system regulates climate. So it's not Lynn who's going to introduce, but it is, yes, come on up.
Thank you, President Mark. It is my incredible pleasure to introduce Dr. Azmaret Asafal Berhe. She's a professor of soil biogeochemistry and Folasco Chair in Earth Sciences and Geology at UC Merced. She recently returned to campus after serving for 3 years as director of the U.S. Department of Energy's Office of Science. This is a position that requires presidential nomination and confirmation by the Senate. The Office of Science is the nation's largest federal sponsor of basic research in the physical sciences, fields such as physics, materials science, computing, and chemistry, across hundreds of universities, national labs, and other institutions. It's also the lead federal agency supporting fundamental scientific research for energy productions and security. Professor Berhe's own research interest lies at the intersection of soil science, geochemistry, global change science, and political ecology. Professor Berhe's work seeks to improve our understanding of how the soil system regulates the Earth's climate and the dynamic two-way relationship between soil and human communities. Numerous awards and honors have recognized her scholarly contributions and efforts to improve equity and inclusion in STEM. She is an elected member of the National Academy of Engineering, a fellow of the American Geophysical Union and the Geological Society of America, and a member of the inaugural class of the National Academies of Science, Engineering, and Medicine's New Voices in Science, Engineering, and Medicine. Very interesting. Let's give a warm welcome to Professor Azmaret Asafal Berhe.
Good afternoon, everybody. Thank you very much for inviting us to join you today. Really delighted to tell you about the work that we do in my lab at UC Merced. But before I started, I wanted to say how wonderful it is to join a group of Rotarians because my mom was a longtime member of the Rotary Club where I grew up. And so I used to always hear about it growing up. So this was really wonderful to be able to join you today. Thanks to Mona for that very generous introduction and everybody that made this possible today. Okay. So wanted to tell you a little bit about the work that we do at UC Merced and especially in my lab. But I wanted to start a little bit with giving you an introduction to our campus. So of course, UC Merced is the first research institution that was created in the country, the first institution of higher learning with a focus on research, of course, is what that means. That was created in the country in the 21st century. As far as we know, it might still the only one in the running. And of course, many of you might be aware of the long history of how the UC system decided to create a 10th campus and why it was located in the Central Valley, in particular with serving underserved community and trying to do higher education better, right, as a system. And I think we've lived up to that promise and more even, I believe. We're now we're now a university in the state that serves a large majority of underserved students, including 61% of our students being first generation students. We have a little bit less than 10,000 students that we serve right now across many different majors and degree programs and graduate programs. And we're really getting quite a lot of national and international recognition right now, only about 20 years after the campus was opened to students, including recognitions that are really critical in my kind of field of research of recognition for being the first university to achieve carbon neutrality, building portfolio of research projects and federal and other support for research that folks at UC Merced are receiving. We were incredibly proud earlier this year to be named by Wall Street Journal as the #1 campus, university campus in the nation for upward social mobility. Because as I mentioned earlier, this was a really, thank you. This was a major reason why the UC system decided to locate this 10th campus in the Central Valley. This is the main reason that many of us moved to the Central Valley from wherever we might have been. I myself was I went to school at Berkeley. My PhD and postdoc were at UC Berkeley, and then later on at UC Davis, and decided to move to Merced to start my academic career, and moved up through the academic ranks in the University of California, Merced, where I've now been there for almost 16 years. So not quite the beginning, but I've seen the campus from when it was super small to where it has grown to be right now. And it's not even just the #1 recognition for upward social mobility, even though we value that a lot because it's really in our mission. But it's also the fact that the recognition is kind of happening across the board in terms of the work that we've been able to do in such a relatively young campus with very little resources compared to research universities. I think what the campus has been able to achieve is incredible. And Wall Street Journal also names UC Merced as the number 18 best university in the nation right now. All of these are unprecedented type of recognitions for a very young campus and relatively small and young campus. And another one that's even, two things that really stand out for me are the fact that we've tried to build this incredible research university, try to do it in an inclusive manner, so pursue inclusive excellence across everything that we do. And we've built the campus in a way that innovative interdisciplinary research becomes the cornerstone of how we served our students and our community. And that recognition is incredibly important because most of the universities that you will hear about as being notable in terms of contributions to upward social mobility mostly are teaching-focused universities, which obviously is a great role and an important role that they play. But we come at it slightly different angle because we believe research provides our students an incredible advantage when they go on the job market or when they want to pursue higher education later on. And that is another thing that we've been achieving incredible amount of success in, which many of us who we know faculty hired in the UC system are research faculty. So a big chunk of our responsibility is in the research space. So we feel particularly proud of the fact that right now UC Merced students are only #2 in the University of California system in terms of the proportion who go on to pursue graduate education. The only campus that surpasses us right now is UC Berkeley. But I want you to stop and think about how that works, right? UC Berkeley does this by catering to the elite of the elite in the student population that we're able to recruit in the state of California. We do it by uplifting our students who never had access to higher education and be able to not only succeed in their undergraduate education, but also be involved in research. And many of them then go on to pursue graduate education, which ultimately, of course, ensures that their leadership potential is even better than what it would have been with just a 4-year degree. So incredibly important number of successes that have been registering, but we're not stopping there, right? Because we obviously want to keep building. We want to keep building and going forward to continue to support our students and our community for social mobility. We want to continue to excel in the quality of education and the services that we provide again to our students and the whole community, and really continue to kind of achieve this broader mission of not just education in terms of kind of the narrowly focused fields of education that we might study, researchers like me, but broadly kind of serving our community across the board. Okay, so happy to talk about UC Merced afterwards if you want, but I thought I would tell you a little bit about what kind of work I do in particular. I'm a soil scientist by training. I love soil. I think soil is one of the most fascinating things that there is in the world. And I know many of you, if you've never thought about the science of soil, which I hope is not true, but if you did, you might be wondering, why is she saying that? But I think that's true because soil happens to be the most complex biomaterial that we know of anywhere in the Earth system. And it also supports more life, more abundance, and more diversity of life than anywhere in the Earth system. A handful of fresh soil that you can hold within the palm of your hand can include more living things than there are people on the face of the earth. That's how important soil is for life. And we're talking about a handful of soil that rests in the palm of my hands that can have anywhere up to 10 billion individual living things in it. And those individual living 10 billion individual living things can come from anywhere from 5 to 10,000 individual species. Many of them are, of course, microorganisms in the genres of bacteria and fungi and viruses and other things. But just to give you an idea how much diversity we're talking about, some of the bacteria in soil are genetically more diverse from one another than you and I are from the green leaves, plants with those green leaves outside. That's how much diversity we're talking about just within this system. So not just abundance of life, but also incredible amount of diversity of life. And because of that, then soil system holds a lot of organic matter. So what we call basically organic matter is these complex and heterogeneous assemblage of organic compounds that may come from a whole variety of sources. So previously living organisms, whether it's plants or animals or microbes. And they're the byproducts of their decomposition. And so soil includes this heterogeneous mixture of organic compounds that come from the residue that's in different stages of being processed in the environment. And in fact, it's that particular pool of material in soil, that organic matter, that is the reason why soil is so incredibly diverse from a chemical perspective and why it is the most complex biomaterial that we know of in the soil system. And people like me, we've spent our career studying this particular pool of organic matter in soil, which typically is on the order of less than 5% of soil mass. In most of the soils in the Central Valley, when you're driving around, we're talking about in the order of 1% of the mass is organic matter. But that 1% of mass plays a disproportionately high role in regulating a number of the key essential ecosystem processes in soil, including how much life can be there and the diversity of life, how resilient the soil is to how much change it can resist when the different changes are introduced, how much water it could hold, its structural stability, the chemical reactions that can happen in soil, which govern even the availability of essential nutrients in soil. So this is what we study in my lab. And in particular, in my lab, we study the cycling of essential elements. How does carbon come into soil, for example, and it leaves the soil, or how some of it is stored in soil? And in particular, we ask questions around what happens when there is a sudden but important physical change in the environment that may occur because of changing climate. So temperature might change, or precipitation dynamics might change. So it changes the amount and flow rates of water through the soil, or fire can happen, erosion can happen, or tillage and other land management practices can change the physical environment in soil with subsequent implications for how fast it could cycle carbon and nitrogen and phosphorus and regulate a whole range of essential processes in the soil system. So that's kind of what we study in my lab. And we try to do it in a manner that promotes inclusive excellence in everything that we do. So I recognize that, you know, climate change is obviously not a new topic for anybody at this point, but I don't know how many of you might have thought about the way soil enters in this equation. So I thought I would spend a couple of minutes talking about that. So all of us know that the burning of fossil fuels and the change in the way that we use land right now is contributing to about 11 billion metric tons of carbon to be released into the atmosphere from the land to the atmosphere every year right now. And about 15% or so of that emission comes from land use change, but the rest of it is fossil fuel derived. But this has caused, of course, the concentration of CO2 in our atmosphere and the other greenhouse gases to increase quite significantly. Just if you think from the time of the Industrial Revolution to where we are right now, there's been 50% increase in concentration of CO2 in the atmosphere, from about 277 parts per million to now we're about close to 420. But if you think about, you know, at what rate the atmospheric concentration of CO2 has been increasing, you quickly realize that the rate at which the atmospheric concentration of CO2 increases is half about this 11 billion number that I'm telling you about. And the reason why it's about half of that is because
half of the excess emission that we keep releasing into the atmosphere right now is being taken up by natural ecosystems, the land and the oceans, in a process that we call carbon sequestration. So in essence, I like to remind folks that the natural ecosystems are basically bailing us out right now. We're only facing the consequence of about 50% of our actions. But we can't relax on that, because the data that's coming out, especially from the last 2 years, is demonstrating that the ability of natural ecosystems to do that, this is dropping in a very significant way. So we can't count on this bailing us, basically continuing to go forward. We have to do something about it. So where does soil come in? In particular, it's really important to think of in the soil context, if you've never thought about it, is the fact that there's a lot of carbon in soil. And that carbon is basically a product of plants taking out CO2 from the atmosphere during photosynthesis and use that carbon to build their green biomass. And that biomass then eventually, when the plants die or the animals that consume the plants die, that biomass gets recycled and decomposed in soil system. And most of that carbon will make it out of the soil system as greenhouse gases, but some of it can remain in soil. And so it's that little amount that remains on every cycle, on every kind of annual scale, that contributes to build up of soil carbon storage. So I like to use a bank analogy when we're talking about carbon storage, because what matters at the end of the day is not necessarily how much carbon you're drawing and you're depositing into your account, but also at what rate you're using it up, at what rate it's leaving, right? That balance is exactly what matters at the end of the day. Okay. So we go even further just to demonstrate to you how big this is. So if you think about, we all are accustomed to think about green biomass has a lot of carbon, right? But in reality, there's a lot more carbon in soil than there is actually in plants. And of course, that varies across different types of ecosystems, right? But generally speaking, the overall majority of ecosystems have more carbon below ground than they do above ground in vegetation. And this then means that the soil system stores twice as much carbon than all of the global world vegetation combined, plus the carbon that's in the atmosphere, and then twice over. That's how much carbon there is in soil. And because it's a lot of carbon that exists in the soil pool, then any small change in the rate at which plants draw down carbon dioxide from the atmosphere, or any small change in the rate at which the decomposition of that residue releases greenhouse gases from soil to the atmosphere, makes a huge contribution to the concentration of greenhouse gases in our atmosphere. And so many of us are then involved in trying to think about how can we increase the rate at which plants take up CO2 without increasing the amount that's released. So while maintaining a large pool of carbon in the soil system. And we do this because we recognize, and this is kind of a lot of the work that my lab spends time thinking about, is by trying to think about the mechanisms that allow a lot of that carbon to remain in soil for long periods of time. This is my attempt at representing the carbon with the orange dots, and the brown bits that you see are soil minerals. So carbon persists in soil for a long time compared to if you just left the residue to decompose. It's fall right now, a lot of falls are falling on the ground, but we come back a few months later and most of that is gone, right? Most of that will decompose, but most of the carbon will go back into the atmosphere as greenhouse gases. Some of it will incorporate into the soil system. But if any of that carbon actually makes it into the soil and is able to form associations with minerals in soil, so minerals being this broken down bits of rocks that exist in soil, the sand and the silt and the clay, if any of that carbon is able to form either physical associations, so either be entrapped inside those aggregate spaces, or form chemical association with minerals, meaning it forms chemical absorption on the surfaces of those minerals, then it's able to resist fast rate of decomposition. Microbes just have a hard time decomposing that because it's energetically very costly and expensive for microbes to decompose the carbon that's associated in that way. So that's what we work on, is trying to think about not just increasing the whole carbon pool, but specifically thinking about these pools that can remain in soil for a long time. And I like to describe those as a checking account. They're basically, we all feel rich in the beginning of the month when that check from wherever it's coming hits our bank accounts. There's a lot of money, right? But most of us will have to pay bills with that money. And so once we pay the bills from that checking account, there won't be a whole lot in that checking account. But if we can figure out a way to store a little bit into that saving account that represents this organomineral association of the carbon with the minerals in soil, the checking account, then we can build quite a lot of carbon storage in soil. So that's what we study. That's the kind of work that we do. And this is just to show you that so soils are wonderful. Soils can help us address the climate crisis. But right now in the world, about half of world soils are considered degraded, meaning their potential to actually support plant growth is compromised. And because of all sorts of human activities that are represented by the different colors here, tillage and erosion and other things. And that has meant actually that if we look forward into the end of this century, we're going to lose a lot more carbon than is already in soil. And this is after we've lost a lot to get to this point. About 120 petagrams, which is equivalent to 120 billion metric tons that used to be in the top 2 meters of soil, is currently up in the atmosphere because of human actions. So this is what the degradation and overuse and abuse of soil has caused so far in the Earth system. So people like me then start thinking about, okay, so this has contributed to change in the atmospheric concentration of CO2. This figure is a little complex, but I'll help you figure it out. So this is the concentration of CO2 in the atmosphere. Obviously, it fluctuates by a whole host of factors. The colors are representative of when it happens, when it happened in the Earth's history. So when was the last time we've seen this kind of concentration of CO2, the red being about 90 million years before present. And the blue color is about 0.02 million years before present. So if we are to think about where we're heading, limiting especially warming to 1.5 and 2 degrees, which are where scientists believe that we need to be to avoid a lot of the big catastrophic impacts of climate change, we need to think about diversified solutions. And what that means really is, if we're going to avoid that emission scenario, if that would occur under very kind of high emissions, business unusual, we keep going what we're doing in the world, the global population keeps increasing, we end up in that high emission scenario as business as usual. The world hasn't seen anything like that in the last almost 100 million years. Nobody wants to be there because that's a very catastrophic situation. But if we just focus on reducing emissions, so we replace our fossil fuel burning with renewable energy sources that don't release as much greenhouse gas into the atmosphere, we can stabilize where we're expected to be. And that's a middle of the road scenario that works, but it's still a lot because it's a situation where the world hasn't seen anything like this in about 3 million years. But if we were to figure out a way to reduce emissions and then enhance a lot of carbon dioxide drawdown using natural processes like soil and forests and the ocean, if we can induce these climate smart management practices in our ecosystems, then we don't only just stabilize at this reduced emission scenario, but we actually bend the curve towards something more sustainable, and the world continues to be livable is the idea. So if you think about soil in particular, there's a ton of potential where we could do that, including especially in forests where we can avoid deforestation or put back forests where they had been deforested in the past. But it's also significant to notice that the purple bars are demonstrating the potential that exists in working lands. If we were to change how we manage working lands, agricultural areas, grasslands, then there is a significant potential of drawing down CO2 from the atmosphere. In the same manner, we could do it with wetlands. There's a lot more detail in this that we could talk about if folks are interested, but I will move on just for the sake of time. But I'll just mention that, I've been working on this space for almost 3 decades now since I was a grad student. I also really believe it's important that we're communicating with the community and the folks that don't necessarily think about soil and carbon in the way that I do day in and day out. So if anything I said today is interesting to you, I encourage you all to check out 2 TED Talks that I've done over the years. In particular, the first one focuses on the work that we've done in my lab and the kind of work that I just described to you. And the second one is broadly on some of the larger scale efforts that are going on, including the work that we were doing at the Department of Energy. And if you have kids, or if you want to share this with students, I especially love that the cartoon. It's a 4-page comic that actually describes what I just explained to you in a kind of friendly manner to people who are not necessarily in our field or even younger folks. And I'm not by far the only person who does this kind of work at UC Merced. We're building an incredible groups of scholars who are leading really in many ways across soil and water and sustainability, regenerative agriculture, carbon sequestration, climate change, and many, many other of these areas at UC Merced. So I could do my best if you have questions to address and about any of their work too. And with that, I will stop talking, but I'm happy to take any questions that you all might have for me. Thank you, everybody, for allowing me to tell you about my work. I see that there's a question on Zoom.
Hello, I have a question. Ma'am?
Go ahead.
If the carbon in the atmosphere were to increase by a factor of 3 to 5, let's say, would that harm either the plant life on Earth or the mammalian life on Earth?
All of the above at 3 to 5 times. Because at that point, we're talking about significant change in the rate at which plants can grow and the health of plants, the nutritional value of plants. All of these things get affected by the climate and both the warming as well as the water stress that would occur on plants across large areas of the world. Of course, there are some areas that would benefit that are currently covered in ice. So that's a slightly different story, but there's a different concern with those that we could talk about. But as far as plant growth is concerned, it would suffer quite significantly. And of course, anything that affects plants being at the base of the trophic structure for terrestrial ecosystems, meaning every living being depends on that. And so it would have consequent impact for all living things. Yep.
If the present rate of emission of CO2 by human beings were to continue, how long would it be before we reached a point where we were, let's say, twice the CO2 level in the atmosphere?
So depends on where you start counting to say twice, because if you're thinking about the 1750 as a benchmark where a lot of people do for this kind of calculation, then it'd be close to the end of this century. Somewhere around there, depending on what our how much we use CO2 and other greenhouse gases we end up releasing the atmosphere. But we're decades away from some, even more significant change than the ones we've seen already. Because I don't think anybody is wondering whether climate change plays an important role anymore, because even lately we've seen some really, really extreme climate events quite occurring with quite, kind of rapid frequency than they are expected to do. So we're already at that level. The ecosystems are already experiencing the change. The question now is, how can we figure out a way to slow down the consequent change? Because it will take a while, even once we stop, this high rate of emissions of CO2 in the atmosphere. Even after we stop it, it will take a minute before the atmospheric concentration stabilizes, the ecosystem processes stabilize. So, any person who works in this field would say, right now is the time we need to do stuff, everything. I don't think it's on. Yeah.
Okay, thank you. As we all know, California is a major agricultural state with a lot of pasture land and fruit trees and et cetera. What are some practical ways that farmers could or should be doing to encourage carbon capture in soil?
Yeah, and California is also an prime example of how we can change management practices without significantly sacrificing cost or productivity of the plants to get this right. There's a lot of demonstration and research, not just small scale research, but large scale demonstration that has happened to demonstrate that. So if we manage soils by avoiding excessive tillage, by avoiding excessive application of agricultural chemicals, in particular nitrogen fertilizers, which actually cause a lot more nitrogen
nitrous oxide release into the atmosphere, another major greenhouse gas, even more global warming potential than CO2. So if we could reduce that, if we can figure out a way to bring back residues, including from municipal waste and other sources back into soil from composting, sometimes even biochar and things like that, we could see quite significant carbon accumulation in soil, i.e. drawdown of that carbon from the atmosphere to soil. And this is great because it's a win-win solution. Soils that have a lot more carbon can hold on to a lot of water and nutrients. And so the farmers do benefit. Of course, there's a cost of implementing these practices. They're not easy. They take time and energy, but the land managers that have done it across the state would speak of incredible benefits they see once they actually implement these processes. And that's why the state of California, even at the state level, has become really a leader in this space to demonstrate how you could do this right.
Thank you.
I'd like to thank you for the excellent talk, very educational. And I was wanting to follow on a little bit about the point you was making about desertification, if you will, and in particular is the possibility of reversing that process. If you look at the Sahara, think of the amount of potential that's there. And wondering if you could address that.
Yeah, so there's a lot of research on what is termed as the greening of the Sahara or greening of deserts, right? So it's theoretically possible. The only thing we have to remember is it takes a lot of time, energy, and there's a carbon cost of doing that too, in delivering agricultural supplements, in delivering water through irrigation to ecosystems that don't have a lot of it. But there is a lot of evidence, for example, in the southern part of the Sahara in Africa and many other deserts around the world, that you can increase carbon sequestration in soils, even in desert soils. But again, we have to be mindful about what does it cost to get us there. And a lot of people would argue that there are cost-effective and much more realistic solutions with land that we're managing right now, because we need to manage those lands to be healthy anyway, because we need them to continue to provide food and fiber and all of our needs for not just today's population sizes, but a growing human population. So we can't afford to degrade any more land anyway, so might as well protect the land that we have and expand reclamation of degraded soils. Because that is a lot more within our grasp, economically speaking, is also we know where the solutions lie. We know what we need to do. We just need to figure out a way to invest properly in land managers so that they could implement these solutions.
So first, let me say I was really impressed and re-educated really with your introduction of UC Merced. And so my question is really related to that. As you interact with undergraduates and perhaps graduate students, how satisfied are you with their awareness of climate change and their interest in taking remedial action? And what do you think the future is there?
I think, frankly, one of the most hopeful spots of doing this kind of work, which can be quite depressing, as you can imagine, because you're constantly talking about some grave global challenges that human populations have to deal with. But probably the brightest spot is dealing with undergraduate students, because this next generation of students are engaged, they're learning, they care, and they want to do everything in their power to actually steer this massive ship, if you will, in the right direction, because their future literally depends on it. They can't afford to continue on business as usual because their lives are already being made difficult by climate change. The lives of their children are definitely going to be a lot more difficult, especially unless we do something about it, and something major. So I think it's not unique to UC Merced students, but I do a lot of public speaking, and everywhere you go, I think the one universal thing is young people are engaged, they care, and they want us to do the right thing. Yep.
In light of SGMA, the Sustainable Groundwater Management Act, and so many acres from 700,000 to 1 million acres, which are asked to go fallow at this point, are you working with the agriculturalists in terms of helping them work with this fallowing and perhaps making it so that they can have more sequestration at this point?
Yeah, in fact, we had a pretty big symposium on this land repurposing that's supposed to go into SGMA, or the Sustainable Groundwater Management Act, that some of you might be aware of at UC Merced last week, where folks from across the region came by to think about how do we do this, right? I think the requirement is SGMA. I think it's important to be clear, is not to fallow close to 1 million acres of land, but rather to achieve water conservation at the level that which you can do with following about close to 1 million acres of land. And a lot of the practices, the climate smart land management practices that I talked about, also contribute to that. In fact, there is a carbon cost that we pay from excessive irrigation, actually. Excessive irrigation doesn't just contribute to releasing of a lot more CO2 into the atmosphere, both from the irrigation schemes themselves, but also from how we're providing excess water that's not needed into the soil, which instead of fueling CO2 release from soil, it actually releases methane, which is a lot more potent greenhouse gas. So methane is about 30 times more potent, depending on how you see it, than CO2 in terms of greenhouse warming potential. Nitrous oxide is about 270 to 290 times more potent greenhouse gas than CO2. So you can imagine how, horrified we are at the level of CO2 that's being released into the atmosphere. Excess irrigation releases more methane and nitrous oxide into the atmosphere. So managing that excess water is beneficial for a lot of things. And a lot of the climate smart land management practices actually contribute to less water being used, because the excess water is not necessarily needed for the plants. But in addition, it also causes all of these excess greenhouse gases and pollution of surface and groundwater systems that folks in the country, in the state and many other parts of the country continuously suffering with. So there's a lot of us, in fact, some from my colleagues at UC Merced, let's see if I can get back the slide, Josh Veers, who's a hydrologist, who's also Associate Vice Chancellor for Research at UC Merced right now. He was one of the top people that brought the group to UC Merced last week, and has been coordinating across our school and beyond to really help engage as many people as possible as we think about where do we go from here. We need to address these issues, but we could do them, thankfully, in a way that is a win-win solution for multiple issues.
So let's give our speaker a round of applause. Okay, don't slip away.
Thank you.
So as our tradition, we have a small gift for you, a bottle of red wine, or a bottle of white wine, or a bottle of olive oil. Which of those three would you like to do? Life is full of hard choices. Olive oil. Very good. All right. There we go. Thank you very much.
Thank you all.
Okay, we've got a couple of items left on the agenda here. What's that? Yeah. Do these glasses look familiar to you? If you left them last week and did not retrieve them, or if somebody you know left them, I'd be willing to trade these for a small donation to a. And we have 3 people taking off their glasses to make sure they actually have their glasses on. Appreciate that sort of double checking. Okay. Well, these may be one of your guests or someone you brought. If someone's missing this beautiful pink pair, I'm going to hang on to them and wear them occasionally during the week if they don't get claimed here. And we'll be back next time. But if somebody is missing a pair of glasses, we'd love to return those and give them the wonderful opportunity to give. Which is, we are a service club after a while. Okay, now, do we have a winning ticket? We do have a winning ticket. Very good. Yes. 126 is over here. We've got Joel. Oh my goodness. What a wonderful opportunity, Joel, for you to pull a marble. The best of luck to you, especially if you're thinking of giving some of that back to the club. And even if you're not, I suppose. All righty. Okay, so next week, we've got Dennis O'Brien and our panel of veteran students. And so that's going to be a fantastic program as we celebrate Veterans Day on that. And then one last pitch again, remembering we're going to continue all week long to be growing a beard on your behalf. So if it so strikes you to go in, even a little tiny gift there adds up. So we're almost 20% of the way there. We've got a few more weeks to go. So if you just haven't thought about it, go on in and make a donation. And with that, we'll call it a day. Thank you very much.